Today we're talking about Python testing and exceptions, and we'll cover a lot of topics in software testing in general. A quote from Gemini: "Software testing and exception handling are essential components of quality software development. Testing identifies potential defects and ensures the software meets requirements, while exception handling prevents unexpected crashes and provides a way to recover from errors. By combining effective testing practices with robust exception handling, you can create reliable and user-friendly applications." And I agree. So let's start with software testing. This is a critical component of the software development lifecycle, and this ensures that applications function as intended, meet all of the user requirements, and maintain reliability under various conditions. Thorough testing helps us identify bugs, security vulnerabilities, any performance issues before they impact our end users. Ultimately, this saves us time, resources, and can often save our reputation. By implementing a comprehensive testing strategy, as developers, we can improve the quality of our code, enhance the user experience, and reduce the risk of any post-release fixes, which can be very costly. Testing also facilitates smoother updates and maintenance, and we'll see how this can help us as developers as we are updating and maintaining our own software. And we can also use testing to comply with industry standards and regulations when needed. My motto is test early, test often. When I'm developing a project, I typically have at least 3 windows open. The first one being my main code, the code that I am implementing, and this could be a sequence of files or a single file. And then I have all of my test suite open next to it. I like to create tests as I'm creating the code and then immediately run those tests. So I keep these 3 things open side by side as I'm developing. I make changes to the main function. I include testing for the new features or functionality that I've added, and I immediately run those tests. And I continue doing this process. And it's not to say that I do this line by line, but certainly as I get a method implemented or a new feature added or a functionality change or something like that, I make sure that the test is either created or, if need be, if it already existed, updated, and then run it. And so by the time I'm done implementing my product, it is already fully tested. Those test cases are ready to put into the CI/CD or continuous integration, continuous deployment pipeline and be ran as code is deployed. So that gives me as a developer confidence that when I am updating and creating new products, that they are going to be tested, and I am not going to have the embarrassment of having my product be one that fails for the end user. There are different types of testing. Unit testing, which we'll go into more detail today, is verifying individual components or functions of the code. Integration testing checks how different modules or services work together. I learned as an undergrad, I believe my freshman year, where I did a research into the failed Mars Polar Lander mission. And the result of my research was that better integration testing could have mitigated that risk and prevented that failure. So integration testing is very important. We often, as developers, do unit testing because that's, of course, testing our code that we're developing, and as I do it in real time. But integration testing is very important. Once you get different modules together, you need to test them together and make sure that they work well together. I call this end-to-end testing. When I deploy a product, I do a lot of unit testing while I'm doing my development, but at the deploy stage, that's where I do a lot of end-to-end testing or integration testing. There's also functional testing, which is ensuring that the software meets the specified functional requirements. Performance testing, evaluating the system responsiveness and stability under various load conditions. So you might also hear of this referred to as load testing. Security testing, of course, is identifying vulnerabilities and potential security breaches. So this is testing for risks. You may have heard of pen testing or penetration testing. That falls under security testing. Usability testing is assessing how user-friendly or intuitive any interfaces you create are, how usable your software is for the end user. Regression testing is confirming that recent code changes do not adversely affect the existing functionality. So as I stated, when I'm updating my code and adding new features, I'm also updating the tests at the same time. And then I have my CI/CD pipeline set up so that it is running my tests. And those tests are then doing regression testing as I am pushing updated code for new features or changes in functionality. Acceptance testing is determining if the software meets the business requirements and is ready for delivery. For example, you might have your stakeholders or individuals that are responsible for interfacing with the client who is using the product, make sure that it is doing what the client wanted the product to do, and so on. Stress testing is examining the system behavior under extreme conditions. So what happens when you reach your limits of performance testing? What happens when your software reaches its limit? Is it going to crash? Is it going to start behaving erratically, returning bad information? Is it just going to simply slow down for the user? So we want to know, how is that software product going to behave under the most extreme conditions, and that's stress testing. And finally, compatibility testing. Certainly, if you're creating a web app, you're doing a lot of compatibility testing, because here you're checking the performance of the software across different environments, different devices, and different browsers. So with web apps, I am often testing my web apps across different browsers, but also looking at different devices. Is it going to work? Is it going to look nice on a phone? Is it going to look nice in a Windows environment versus a Mac environment, and all of the different browsers? And I typically try to test against at least 3 or 4 different browsers, but there are so many browsers, environments, and device combinations. It's difficult to test them all. And we'll discuss that further as we go on through this lesson today. So I set up a simple test example to start with. And in this test example, I have created some images here. And these images coincide with the diagram I created above. This is my main function that I'm implementing, and we have the code below, so don't worry if this is too small to see. This is my test function, and this is my terminal or command prompt that is open. And you can look at each of these images closer if we want to open it in a new tab and see it a little bigger. This is the result of a test case that I ran. And as I said, the code for the main and the test that we're going to talk about here is down below for you to copy. Let's talk about what this program is. So this example code that I've created is going to demonstrate a basic function, so a single function that cleans input text and separates the words. So this is a common task in natural language processing, or certainly any application that needs to do some form of text processing. Then I create some unit tests to test this function. And here I'm going to use the popular library called PyTest. PyTest is used a lot for unit testing. Now, Python does have its own testing module, but I think PyTest is a little cleaner and easier to use. At least it's my favorite, and I know that it's quite popular. I have a link to PyTest here. If you would like to read the documentation, go through some how-to guides, there's a nice getting started tutorial, and then simply a quick example here showing the content of a test with a function and a test function and the output in this case showing a failure. So we're going to run some tests on the example code I have here so you can see what a successful execution with PyTest looks like and what a failure looks like. Here's some tips with PyTest. When you are naming your test files for PyTest, if you follow the convention of using test in your file name, for example, test underscore as a prefix or underscore test as a suffix, then that naming convention will allow PyTest to automatically discover and find your tests. Additionally, provided that within your test file, your test function names also start with test underscore. So we'll use this convention in these examples, and you'll see that with that convention, we can simply run PyTest without adding any file name, and it will find and execute the test cases for us. So that's just a tip to make things a little bit easier. Here are the two pieces of code that you can copy and save. So first we have a function, and this function cleans words. So it takes as input a string and returns a list of strings. And it processes the input text. It's going to remove special characters, convert the text to lowercase, and split it into words. So this is a common text processing task. And so it's going to return a list of words with all special characters removed and the words all in lowercase. When we test this function, we're going to import PyTest, and we're going to import the function that we're testing from over here. And we're going to create, I see I have here 4 different tests that I'm going to run. Test cleaner empty, test cleaner numbers, test cleaner lowercase. So why these 4 tests? If we go back up here, we can see that these unit tests are demonstrating, first of all, basic functionality. Does this function do what I expect it to do? When I input text, is it going to return a list of strings, so a list of words, in the fashion that I expect it to? So that's testing the basic functionality. Then I do some edge case testing. So in our method, or our function, we are simply accepting any string of text, and we don't really have any rules around that. So the only edge case to really test for here is an empty string. So if the input is empty, what do we get back? Well, we would expect to get back an empty array, but we should test for that. So that is called edge case testing. If I had specified that this function has a maximum length string that it will accept, then that would create a new edge case that I would have to test for. If I said that my clean words function can take a string up to length x, then an edge case test would be what happens when the function gets a string that is exactly x characters long, and what happens when the function gets a string that is greater than x characters long. So that would be edge case testing that I would add if I had that constraint on the function. But in this case, my function will just accept any string. So the edge case that I'm going to test for is empty input, an empty string. And then I do some specific testing. So I said that the function was going to remove special characters. I should test and ensure that it does. I said that the function is going to convert to lowercase, so I should test for that. And I said it was going to split into words, so I should test for that. So my first test case here is testing basic functionality. The second test case is the empty string. The third one is testing that it removed numbers, because in this case, I didn't say so in my comment, but if you look at the regular expression here, I'm only accepting letters in these words. So in addition to removing special characters, it's removing numbers, so I should probably add that to my comment here. But you can see from the regular expression that that is indeed what it's doing. And then converting to lowercase, so I'm going to test for that. So how do I set up these test cases? In the first one, I want to ensure that I'm using an input string that is going to test to make sure special characters are removed. So I included a lot of special characters in my input string. So imagine that we're processing a post or perhaps an SMS. what we expect to get back from this is all special characters removed, which is going to include the code for the emoji, the hashtag character, and the exclamation mark. And it's going to split this into words, so it's going to return an array of strings for each word. And it's going to make all of the text in lowercase, so LOL will be lowercase. So I expect the output to look like this. I expect the output to be LOL, this is adorable love, in a list. I use the assert statement to assert that the response from clean words when called with my input text is equal to, so equivalent to, my output text. So this assert statement will assert that any condition that follows it is true, and if it is not true, then it will produce an error that we see in the console when we run the test. In the second case, where I'm testing that with an empty string, I'm calling clean words with an empty string, and I expect it to return an empty list. And so this assertion statement checks for that expectation. I test against cleaning numbers. So if I call clean words with call and then the commonly used phone number, fake phone number, and I expect this to simply return a list with a single string call, having removed the number and the dash characters. Checking lowercase, I'm going to call it with an uppercase word and expect that that is returned in the list as a lowercase word. So these assertions are checking for some basic, simple things that my clean words function is supposed to do. So let's see what happens when I run this with PyTest, which I've imported here. So I'm going to copy the first code. And let's open a text editor. I use Sublime for my code. So I'm going to open the text editor, create a new file. I'm going to paste what I copied there, and I'm going to save this. And I'm going to save it as cleaner.py, which is necessary because if you look here at my test code is expecting a module or a file named cleaner, and it's going to import the function clean words from that. So I need to necessarily name my file cleaner for that to work. Now let's copy the test code. Open another window, paste that code, save it. And I'm going to use the convention that we talked about for naming. So I can either call it cleaner underscore test, or I can call it test underscore cleaner. I like to do it this way because after I save it, the files will be alphabetical and my cleaner.py will be next to my cleaner.test. Now, if I wanted alphabetically all of my test files to be together, which some developers prefer, then I would put test first, and then all of my test files will fall together alphabetically. But I like to keep my code file next to my text file or test file so that it's easier for me to find them and pull them up together. So I'm going to call it cleanertest.py, so it'll be stored right here next to cleaner.py. So I have my test file. I have my cleaner file. Now, of course, this my monitor that I work on is much bigger, and I'm working in a small space here for this display screen, so I'm going to overlap these a little bit. But this is how I like to work. I like to keep everything open along with my terminal, which I'm going to pull in here. And I like to keep them open and side by side, but like I said, they're going to overlap here in this small window that I'm recording in. All right, so if I list what's in this directory, I see I have my cleaner.py and my cleanertest.py. So at this point, I can simply execute PyTest, and because I've used the correct naming convention, it is going to execute cleanertest.py. And if you look at cleanertest.py, you can see each one of my test cases start with test underscore, so they are all going to be executed. That was 4 test cases that were executed, and you see a little dot here for each one that was executed. So collected 4 items, those are my 4 test cases, and all 4 passed. let's see what happens, what it looks like when a test doesn't pass. So let's go back to my cleaner, for example. And let's say that I did not include this lowercase statement. So I'm changing my cleaner. I forgot to do the lowercase. Now I should see these tests fail. I should see the first one fail because LOL is not going to be converted to lowercase. And I should certainly see this last one fail because yes is not being converted to lowercase. So let's run the test case again. And I see those two errors. So the first assertion error, so right at the top here, I see more detail from PyTest. And then below, I see the short test summary. So let's start at the short summary. So I see 2 tests failed and 2 tests passed. And in the summary, I see the assertions that failed for each of these. And then at the top, I see the detail. And the detail is telling me that this assertion failed. Text in does not equal text out. There was an assertion error. And it's telling me specifically where the assertion failed. LOL does not equal lowercase LOL. And here, uppercase yes does not equal lowercase yes. So PyTest is telling me exactly where my tests are failing so that I can go back and correct my code. I can go back, fix my code, run my test, and I see all 4 tests passing again. So let's get these out of the way for now. Go ahead and close my tests and my code. And look at another example. So the next example I've provided here is demonstrating using PyTest again, and here we're using a pre-process function that goes a step further. So this function is going to use some actual natural language processing toolkit methods to go a little bit further into the text processing. And in this case, we are also, in addition to doing some of the same text processing we did before, our pre-process function is going to tokenize, use the word tokenize function in Natural Language Toolkit to tokenize the words, again, convert them to lowercase like we did before. So we have a string of lowercase words, which we'll call tokens. And then we're going to remove stop words. So stop words are the small words that don't contribute a lot to a sentence. And we'll see what they are when we execute some of this code. We can see some of the stop words. So we're going to import stop words from NLTK, and we're going to return here. Now we're going to return a string of tokens only if they're alpha. So again, removing special characters and numbers, we're only going to remove, keep alpha characters, so words, and only those words that are not in stop words. So this is going a step further, and this is preparing the text for a natural language processing pipeline so that we can then use the text in model training for different purposes. So I can copy this code, and what do I want to name this? So here, look on the right here, we see my test code. So my test code is importing from, it's importing preprocess from preprocess. So I've named my file the same as the function that I want to test. So I need to name this file preprocess. I'm going to copy that. Let's open a new text editor, paste it, save it as preprocess.py. All right, so that's my new function that I want to test. And let's grab this test code, copy. New text editor, paste that. And I'm going to save this. I'll go ahead and do it the other way this time, just to confirm that that works as well. Test preprocess.py. Save that. So if I look at my test cases now, I'm testing first for basic functionality. So if my input text is the frog is on a log, after converting everything to lowercase and removing the stop words or the words that are not contributing much, I should expect back frog and log, because I know that the is on a are all stop words. So those are going to be removed. So that's my input text and then my expected output. And I have my assertion that pre-processing the input text is going to return something equivalent to my expected output. Again, I'm going to process for a test for an empty string. So pre-process empty test here. That running this returns an empty list. I'm going to test for stop word removal specifically, which I've already done by testing functionality. But in addition to your basic functionality test, you do want individual tests for each thing that your function is supposed to do. So I'm explicitly going to make sure that stop words are removed in this one. So this is a test of the function, should reduce to a list of test function. And here I'm testing for only getting alpha characters. So this is hello to the number 7, and I expect to get back just hello because we're only keeping words with alpha characters. So this is not a very comprehensive test case, but it's testing for the main functionality to ensure that those basic expectations are met. Go back to my command prompt. Go ahead and clear the screen from our previous tests. And if I simply run PyTest again, you'll notice that it ran my cleaner test again and then my new test pre-process. So when you run PyTest, it's going to run every test that it finds in the directory that you're running in. If I wanted to explicitly only run PyTest with my new test case for my pre-process function, then I would specify the file name. And by specifying the file name, then I only run that test. So without specifying the name, both of them ran, and it ran 8 tests that passed. And with the specification it only of the file name, it only ran those tests in that file. And those 4 tests passed. That was just another example. For those of you studying natural language processing, we also want to look at exception handling in Python in addition to testing. So in Python, the language contains built-in exceptions, and these exceptions, which you've probably already seen a lot of, are thrown when there is a syntax or a runtime error in your code. So specifically, the exceptions will be thrown for the runtime errors. And in addition to built-in exceptions, Python allows developers to create custom exceptions. So we're going to look at an example of testing with both a built-in and a custom exception next. I have a link here to the Python documentation for the built-in exceptions, and you can read about the exception context, how you inherit from a built-in exception when you're running your creating your custom exceptions, and the base class, base exception, which all of the exception classes inherit from. And then the base classes, which your custom exceptions could potentially use. So there's the main base class that everything inherits from, and then additional exceptions. So the base exception class, and then arithmetic error, buffer error, lookup errors. So some of these you may have seen, assertion errors, attribute error, EOF, so end of file error, floating point generator, import, and so on. Module not found error. I think new developers see this one more than any when importing modules. And this is a list of simply all of the errors that are built into Python. So if you ever get an error and you're not sure why was this exception thrown? Why am I seeing it? Look at the name of the error. Go here, look it up, and read what raises this error. The memory error is raised when an operation runs out of memory. So this is helpful documentation for exception handling. And when you are creating your custom errors, you want your custom errors to inherit from one of the base classes, so you need to choose the appropriate base class. So for this simple example, I have created a basic calculator in Python. So let's look at the calculator class first. I created it as a class, so I can demonstrate using classes with PyTest, testing classes. So this class has several methods: add, subtract, multiply, divide, and square root. So add, subtract, multiply, simple methods that do perform those mathematical functions. Divide needs some special treatment because we cannot divide by 0. So when the divide function is called, it's provided two arguments, a and b. So the parameters for divide are a and b is going to be the denominator, and it cannot be 0. So the first thing we want to check for is if b equals 0, we want to raise an error because we cannot divide by 0. So in this case, we will simply raise a built-in exception, the value error. And we can optionally provide our own string that we want output when this exception is raised. In this case, I want it to simply say cannot divide by 0. And in the case that b did not equal 0, this if statement doesn't execute, and we simply return a divided by b. So since we have a couple of different paths through this method, we have exactly two different paths through this method, either the first part executes or the second part executes. We need to test for each of those in our test cases. For a square root function, we cannot take the square root of a negative number. So the first thing we check with our parameter, we see if the argument that was provided is less than 0, and if so, now I want to raise, so I could simply raise a value error here. And this would really, the way to do this would be to raise a value error that would say something like you cannot take the square root of a negative number. But to illustrate creating a custom function, I created a custom function called negative square root error, and it's inheriting a value error just to provide you with an example of the syntax for creating a custom exception. In this class, I have an initialization that takes whatever value was sent to it and creates a message that says you cannot get the square root of the negative, and then includes the value that was seen in the message. And then, of course, I initialize super, which is the class that I'm inheriting value error. So this is just illustrative to show you an example of what that syntax looks like, but I could have certainly used a value error here again. And again, that square root function has two paths through it, so I'm going to test for both of them. So if I look at my test cases, first of all, I want to test every function for the calculator: add, subtract, multiply. And for divide and square root, I want two cases. So I have two different types of assertion statements here. The first one, the assertion statement that we've seen before, where when we call the function, the result that we get is equal to our expected output. And when you are using PyTest to test if a method or function raises a particular error, this is the syntax for checking for that. So I can say with PyTest raises. So PyTest has a raises function that is used for asserting that an error gets raised, and then the test code will continue executing. So it will ensure that the error was raised, but it will not crash because we want it to continue testing. So that's what this function will do. So for test divide, when I call divide with 0, I expect it to raise the value error. So this is the syntax with PyTest for asserting that the value error is raised when I call divide by 0. And similarly with test square root, I first have an assert statement that tests a case where I should get the square root. The square root of 4 is 2, so that's my expectation there. And then I want PyTest to assert that if I send a negative number to the function, the function raises a negative square root error, which is my custom exception that I created. Now, in order to use my custom exception, I need to import it. So I am importing from calculator, which I'm going to have to name this file calculator then. I'm importing the calculator class and the negative square root error class. So I can use these in my PyTest test code. Another thing I did here, notice that each one of these functions is going to require an instance of my calculator class to execute. PyTest has a fixture that you can use to create an instance for each test where you only have to write this code one time. So you use the PyTest fixture decorator on the function, and this function calc is going to return an instance of the calculator class. With this fixture, for each of my test cases, I can simply put as an argument or as a parameter the calc function, which is going to return an instance of my calculator. So this way I don't have to create an instance of the calculator within each of the individual functions. I can just do it one time, implement the code one time here, and then send it as a fixture into each of my test cases. You'll find that this comes in handy, especially when you find that you need a fixture that requires, for example, instantiating an instance of a class and then doing some other configurations. You don't want to have to repeatedly do that in each of your test cases. So in this case, all we did was instantiate an instance of the class, but we could have done in any additional other steps that needed to happen within this fixture so that we only had to implement that code once and then send the fixture into each of the test functions. So each of our test functions, notice this fixture does not start with test, so it will not be recognized by PyTest as a test function, but the rest of these, test, add, subtract, multiply, divide, and square root, are going to be recognized by PyTest as test methods, and they are going to be executed when we execute the test. So let's give this a go. We'll copy this one. Save this as calculator. And we'll copy this one. And save this as calculator test. Did I fail to put the code in there? I failed to paste the code in there. Pull that back up here. Paste. There we go. Save it again. All right, so I have my calculator test, and I'm going to go back to my terminal, run PyTest, and I see my calculator test got ran and all of the tests passed. So I've now got 13 tests in there, and of course I could have just ran the calculator and executed that. The next thing I want to look at is we talked about testing all of the different functions and how we needed a couple of different test cases to handle these functions where there were different paths that the execution could take. We call this test coverage. In test coverage, we want to test for every line of code, which means testing for all possible inputs, testing that our test suite executes every line of code and tests for all the different ways we can go through the code. And that is certainly not always going to be practical to do that. So there is some text here on this site that I left for you to read. I'm not going to read it to you here today, but this is talks about test coverage and what we are striving to achieve with test coverage, why it is hard to get 100% coverage, and what we can aim for, and what we should really look at as our test suite as a combination of things in general, and in addition to test coverage. This actual text content information here, was written by Claude AI. I have read through it and confirmed that it is well written, and I agree with all of it. But I asked Claude to create a disclaimer. So the disclaimer is that this disclaimer was also written by Claude AI. And the disclaimer here is that this entire section was written by Claude AI. So with a simple prompt, asking Claude to talk about testing, talk about why we want to achieve 100% test coverage, why it is difficult. Specifically, I requested talking about the combinatorial explosion, because if you think about the number of possible inputs to your software, if this is complex software, the possible combinations of inputs and the execution paths through your software are going to grow exponentially. And if you remember your big O notation and you remember learning about time and space complexity, you can think about the fact that it is going to be very impractical for a very complex software product to test for everything. There are also things like environmental factors where some conditions are difficult to replicate. There's edge cases that are difficult to trigger when you're testing, and so on. So you can read through this, and I'll provide a link in the description of this video, a link to this website, where you can read through some more details on test coverage and creating a good test suite. But I wanted to quickly, before we close here, show you how to run a test which shows you how much of your code is covered using PyTestCov, which is another module, which I have a link to here, that works in concert with PyTest. You can install it with pip. And then you can run PyTest using PyTestCov. So with a coverage specification of the code that you actually want to test the coverage on while you're running the test. So here, I'm going to run PyTest on calculator test.py, and I want to test the coverage of calculator. So I'm going to copy that, get my terminal back out here. So I'm running PyTest again, but at the same time, I'm checking for coverage of the calculator class. So I can see that my tests passed, but in addition to my tests passing, I got this nice little report here from test coverage telling me how much of my code was covered. And in this case, I have 100% coverage. So if you want to see what it looks like when you don't have 100% coverage, if I go back to my calculator test.py, let's comment out the test for the addition function and run this again. Now we see that I only have 95% test coverage. So that's still good, but you see there's a miss here. If I want to know what those details are, what was missed, I gave you some additional syntax here to get more details from this coverage test. Copy that, paste it here. And I can get more details about what is missing. The statements, there's 21 statements. I missed one of them. And then the statement that was missing, 15. So that line on calculator.py. So I did not test for this. So I did not test the add function. I put that back in and test for that. I can also do, which is kind of neat here, when you have a more complex example, this last one is going to create an interactive HTML page of my coverage report. And it writes it to a new directory. So I'll pull up my file browser here. When I ran that test, with that coverage report equals HTML, I got this. So I got an entire interactive HTML page that talks about the coverage of my test, the files, the functions, the classes, and it's a nice interactive page. So for this simple example, this was overkill. However, you saw how simple it was to simply execute that line of code and then get this nice coverage report. So you can imagine how useful this is when you are testing a very complex test suite. So this is one of the things that I love about PyTest. And I hope you enjoyed learning about PyTest too, and you find it helpful in your Python testing. And I encourage you, of course, to test early and test often when you are creating products. Thank you, and I hope you enjoyed this lecture.